Oh, Amal. Yes, thank you.
Thanks, Anna, for the very insightful talk. So when you say provenance tracking, is it part of your, like a built-in feature in your workflow, or you're using external tools, or you're planning to?
Yeah, so provenance can be at many levels. Right now, we're just looking at what were the codes that were generating this, what was the input file, because these are queries that we're interested in. We don't keep track of what the reasoning is for the reasoning models, for example. So we would like to get as many data as we can, but not as much as we cannot handle it. So we don't have a solution, but I know you're looking at it, so you will hear from me.
Okay,
sure, thank
getting
you.
personal. Right. At the back, Eric.
Hi.
Juliet? Yeah.
Yes, thank you. That was a really interesting talk. I had a question about your metadata management layer. How tightly coupled is that with Frontier, and how
tightly coupled is it with what?
With Frontier, with the system that is running on, and can it be readopted across domains or reused elsewhere?
So it's not tightly coupled at all with Frontier. The examples are on Frontier because that's where I have access to. But it can be anywhere. When I run studies for a paper, I usually create campaigns with all the runs for a paper. And these are very often done on my laptop. So I add those as well. It's just a MongoDB or SQLite database underneath that keeps track of the location. It's nothing specific to Frontier. Also, it's nothing specific to one type of database. Like you have Adios, HDF5, text files, image files. You can put anything in it. It's just that the query engine is going to use whatever that type of database can do. Right?
Patricia.
So I know that at this level that you're working, you don't necessarily care about what platform hardware you're using. But I was wondering if you have some insight about if you wanted to change something on the fabric that you're running on, what that would be, or if I understand at this point you don't care about it. You prefer more to look at it from a higher level perspective that you can use in many different platforms. Mm-hmm. But would you be interested in maybe trying to discover what are those knobs that we could change in hardware to make this more powerful?
Yes, so as you said, we did not look at any of that, right? But if we had compute in transit or compute on the storage, that would be really great, because a lot of the quantities of interest that we're computing are expensive. And we're doing that on the application resources. Again, I don't care necessarily about where the application is running, but I do care about where the data is going through. Yeah, we don't do any of it, but if you have any access to anything with compute in transit, I would be extremely interested.
Okay, yes.
Yeah, I just don't want to take away from anybody else with real questions. Anna, in one of your previous slides, I think it was the last one, previous to this one, you said that you detected drift less than 10 times. Are you going to verify the data every single time you run things, or are you going to get to a point where you say, no, now we are trusting what is coming out?
So, yeah, this is a really good point. Depending on how expensive it is to do continual learning, we will deploy different strategies, right? So in some cases, they just want to know, oh, drift has started to be detected so many times that the model cannot really be trusted at this point, but we don't have the resources to retrain it, so let's just take it with a grain of salt of what it's saying. In other cases, here, the training was pretty cheap, so every time we detected a drift, we retrained everything because it was so easy to create the data sets. So there's no solution yet, it's just more informative at this point, and the application does whatever it wants with it.
Jeff.
Two questions, actually. One of your very first slides, really, it was about the file system limitations.
Yes.
So I think what I saw there was that you're comparing, I'll say, standard traditional HPC simulations with these AI simulations. And basically, this slowdown, it's roughly double, it's twice as bad, I guess, or twice as much for the AI training type. Depending, that's on a number of different file systems or file system types, right?
So these are parallel I/O libraries. The file system is Lustre in all cases, but different strategies of dealing with the data on the HPC side. So the slowdown is basically if you have, let's say you have a large-scale simulation that generates data, you time it by itself in isolation, and then the AI, you run it by itself, reading this data and training a model. And then when they run at the same time, the HPC, the traditional simulation, is going to generate data, so right on the file system in files, in POSIX files, at the same time with the AI trying to read multi-threaded and randomly from this file that is currently being written to.
Yeah.
And that's the slowdown. And the slowdown on HPC is lower because we have caching on the right side, and it's usually just one stream going out.
Yeah. So it's just what you have there in boldface there, in summarized there. Okay, that's fine. The other is just a clarification. It looks like some of your simulations, I mean, this work is primarily done at Oak Ridge, right?
Yes.
Yeah, but you're accessing files across the country at Perlmutter, right?
Yes.
Yeah. Being in a small country here in New Zealand, we obviously do have networks, but I'm used to kind of working right on our system right here. But I just wanted to make sure that that is what's going on. So
that's perfect, and the transfer time is probably much better than in our case, but you still have an issue. You cannot download 1.5 terabytes on your laptop, right? So you still need to deal with how do you just get parts of the data so that you can visualize them on your laptop, even if you can transfer them like this.
We're trying to get people off their laptops and onto our HPC systems, but that's another discussion we can have.
This is another discussion because that's the trend in general, but I think because the data sets are so big and they want flexibility to be able to look really fast at what is happening with my simulation right now. I'm on the train, I just do a hotspot on my phone. It's harder to, right? You could do that if you wanted with this, but yeah, it's a philosophy discussion.
On that topic, join me to say thank you, Anna, before
Thank you.